the second part of webinar. So good evening and welcome to the second part of webinar Explore Hydrogen Natural Gas for Support Green Transition, made by a company with the partner of Qatar Energy. So when we are talking about the hydrogen energy, we are concerned on the three different steps, but company is only involved in the first steps: hydrogen production, developing transformation natural gas decarbonization technology to produce net zero or net negative carbon hydrogen to meet the needs of future hydrogen markets. So it's clear that production of hydrogen is complex because we have, for example, hydrogen transportation, hydrogen storage, that is very important for the distribution of hydrogen, for example, for cars and other areas. What are the focus point of conference or webinar? Data about increased hydrogen request and production, where can find natural hydrogen, type of hydrogen, typical geological rocks and traps for natural hydrogen, the principal method of exploration, comparison of cost between hydrogen and other energy source, benefit in reduction of CO2 emission. Start for the first point. There is the increase of request of hydrogen versus production. We have a high expected increase of production starting from the last 2 years ago, and a good expected for the next 20 years later. We have also an increase of global requests by different sectors, for example, industrial or power and heat generation, that are starting to convert to use hydrogen from the 2020 years. We make a good attention because there is a different type of hydrogens, different type of hydrogen and different type of production hydrogen. We can find about 6 of 8 type of hydrogen. Gray hydrogen, that is production that in which hydrogen is produced by natural gas. The gray hydrogen production by steam reforming natural gas, mainly methane, reacts with water vapor in a high pressure mixture to produce carbon dioxide and hydrogen. And also blue hydrogen, that is a steam reforming also natural gas. Black hydrogen, black or brown, by transformation of coal into gas. Coal is heated about at 600 Celsius degree. Water is added. The mix of carbon, methane, and water vapor is transformed into carbon dioxide. So in these two types, gray and black hydrogen, there is a high production of carbon dioxide. So it's not so green. It's not so green it's not so comfortable for green transaction. And other types, for example, pink hydrogen, that is from a source for nuclear energy. Turquoise hydrogen for natural gas, yellow hydrogen for solar energy, and green hydrogen for renewable energy. And also we have also white hydrogen, that is the focus of this webinar, because white hydrogen is natural hydrogen for natural source like rocks. We are make attention to different type, and we evaluate also the cost of production and effects on footprints. So what is white hydrogen? The hydrogen is commonly we can define white hydrogen. The hydrogen is commonly produced during the high temperature hydration of mafic and ultramafic rocks. Owing to its type of hydrogen is not created by humans, but is found in its natural form as free gas either in layers of continental crust deep in the ocean crust, in volcanic gas, in geyser or hydrothermal system. Hydrogen seems to be present in a wide range of rocks formation and geological region. The basic and most important process is the serpentinization process, that is a natural alteration process of rock containing a high concentration of iron and magnesium by water. This alteration combined with the deoxidation of metal present in the rocks produce a high hydrogen-rich gas and a very alkaline water with the pH upon 12.5. We have also a star map of main hydrogen valley, main hydrogen potential valley in different parts of the world. It's just like linked to margin, continental margin. So we have, for example, in South America, Chile, China, a great part of Australia, USA, and some part of Europe. All of these places are also linked to the presence of continental ultramafic rocks, peridolite and serpentinite, sedimentary serpentinite, and continental basalts. The scheme that is based on the presence and the production of the white hydrogen is the following: is the geological context of subduction with two plates. The first place goes under the second planes, and with presence of basalts or ophiolitic rocks that were serpentinized and in the upper mantle, and the production of hydrogen reservoir in this part. So this is a typical hypothetic scheme of production of generation of natural hydrogen. For natural hydrogen is linked also to sedimentary basin, in particular some type of sedimentary basin with sulfurous rock, degassing of deep hydrogen from earth crust and mantle, interaction of ultramafic rocks serpentinite with fluids, natural water radiolysis, weathering water in contact with freshly exposed rock. The geological context typical is crustal margin and rift and seam rift place. We are about 1, 2, 3, 4. We are about 3, 4 best categorized, best place in where I can find natural hydrogen. For example, fourth zone, continental and deep sea floor hydrothermal volcanic zone, serpentinized subduction zone with the process of serpentinization. In Australia, where is also linked to some basin with methane. There is a map of Europe with state-of-art of project of, for example, deep field attended in next 20 years, developing for the hydrogen exploration project. also to the production in next 20 years. The crustal margin correlation between occurrence of serpentinite and manifestation of hydrogen. That's clear that the manifestation of natural hydrogen is linked to some plate in some place of the world, like crustal margin of rift. We have a high potential also, for example, in this part of Red Sea. Explanation of natural hydrogen formation. There is a typical explanation with also linked to depth and temperature at which the seepage and traps of gas of white hydrogen is starting formation. Generally, we need the first condition is the presence of serpentinite, and the second condition is a depth between 10 or 14 kilometers, a presence also of mineralization, so the presence of water, and here we can start the formation of the white hydrogen. At the surface, we can make a relief on the surface, understand some potential. If you see, for example, hydrogen sulfide, like sulfurous rock, or like this type of rocks, it is also a manifestation of presence of white hydrogen. Geological settings of sulfurous rock in which can be trapped white hydrogen. For example, we have a typical context with layers that are not in plane but are deepest about 20 or 13 degrees, with the faults, with the system of faults like a flower, and in which, for example, we have anhydride or also the faults make in the upper of footwall the presence of serpentinite, which is the physical parameters of hydrogen reservoir. The physical parameter of hydrogen reservoir is around a pressure around 300 atmosphere with a minimum depth of 15 kilometers with a temperature around 2000 or 3000 Celsius degree for a distal subduction zone. We estimated the pressure of 1 gigapascal at 15 km depth, and serpentinite have a stability max at this temperature. As we just see in the first slide, in one of the first slides that resume where we can find the hydrogen, we have this. We have also a fault zone with high probability to find natural hydrogen. The fault zone in crustal rocks once release is highly mobile, buoyant, and almost insoluble in groundwater. A fault system may act as a conduit, allowing hydrogen to accumulate in soil gas. The experience of geological fluids rich in natural hydrogen raises the question about the energy potential of this carbon-free resource. However, to the date, there is no exploration strategy based on robust methodology and pathfinder. So there is a scheme of in which works the hydrogens, natural hydrogens, in a long fault. There is different bubbles, different bubbles at different depth. The bubbling gas, for example, at different depth. So different, as like a small reservoir at different depth. So is a very trouble to understand, because if there are this situation when we are starting to deceive the production, is very important to expanding the porosity of rocks using, for example, fracking. Also, we need to make attention to evaluate the porosity and the way to capture the white hydrogen. Another context is microbial and volcanic hydrogen. Deep sea hydrothermal vents may provide one of the largest reservoirs on the Earth for hydrogen oxidation. Depending on the geological settings, hydrothermal environments can be considerably enriched in hydrogen. And reduced hydrothermal fluids are sent to the seafloor mix with entrained cold, oxygenous water, and chemical gradients along the pathway. There is a typical scheme of production of white hydrogen in volcanic context. So another possibility, natural scheme that reproduces the artificial scheme to produce with electrolysis to produce hydrogen, is in presence of rocks with radioactivity elements like thorium, barium, plutonium, and like that. The presence of uranium, thorium, and other elements with radioactivity decay can favor the separation of hydrogen atoms and the formation of hydrogen gas. Which method of exploration can be used? We have different method of exploration for the different ambient and the different constant, and different geological context. For example, for the ultramafic and serpentinity gravity method, we can use the gravimetric method. For seismic, for line fault, we recommend, for example, combine seismic with high frequencies acoustic image. There is an example of last acquisition that combines seismic and acoustic image. With high frequency acoustic, we can find the very small layer with seepage of natural hydrogen. Also along the fault, we can use electromagnetic survey. We need more attention to the specific characteristics of this gas of hydrogen, because the reaction, the frequency of reaction is about along this value. So it is a very high frequency of reaction. So it's too difficult to make a deepest exploration with these high frequencies. So a long fault is possible, but is not possible in all contexts. For ultramafic rocks, the principal method to make a screen is detecting a range of depth and probability interaction with water fluid. In the following example of gravimetric method that is applied in the region of Pyrenees area. And for natural hydrogen, for example, we have also the fuel gas. We have analyzed also the natural seepage sites, the presence of hydrogen, but we have also to analyze the biological aspects, because there is some bacteria that consuming hydrogen. And we have also an attention to geochemical analyst, because for example, when we are start drilling, we have also to consider by the samples and attention to the thermodynamics or the presence of some minerals that can be absorbed absorb the hydrogen. So we have also a specific model for analyzing flow in porous media. So I've just said hydrogen is a very particular gas, so we need also some advantages, but also some trouble that we are trying to resolve. For example, one of the advantages of use hydrogen is also gray, pink or white, is that hydrogen holds the same amount of energy as a gallon of gasoline, but its volume is many times bigger. White hydrogen is extracted now by fracking, and the first region in Europe that are try to do this challenge is French, and the first project at a depth of 1.2 kilometers, in which we are find the concentration of white hydrogen about 20%. We have also a comparison of cost of production of different type of hydrogen. We can see the natural or white hydrogen. We have the lowest price of production is about $1 for 1 kilos of hydrogen, instead of the green hydrogen that is green hydrogen that is produced by electrolysis, or blue hydrogen that is linked, for example, to methane or other gas. That we have a highest price with $8 or $9 for 1 kilos. As a graphic comparison between other natural fuel. What we can underline that instead the low difference between price of production between methane and hydrogen, it is necessary to consider that the current and future technology will increasing the benefits hydrogen given its low ecological footprint. The footprint is the kilos of carbon dioxide emitted for each kilogram of production. From the latest data of International Energy Agency, I tend to underline that the medium value of emission of carbon dioxide is about 10 kilos of CO2 for kilogram of hydrogen, produced against 18 kilos of carbon dioxide for 1 kilos of methane production. So there is a rapport of 1 to 10. In this scheme we have a different color, different hydrogen and their footprint. With the biggest footprint is clear from gray and black hydrogen that we are produced respectively from methane reforming and black from coal. We have also benefits in reduction of CO2 in all sectors, because the use and large scale use of hydrogen is to link it, for example, to the use of CO2 in steel, shipping and buses. There is also an implication in other economical aspects. And there is a hydrogen decarbonization of steel making for different states, for example in Europe, USA or Sweden. Capture hydrogen for water, for ocean water. Another way for the production of green hydrogen recently with increased appeal is the installation of floating photovoltaic panels with the electrolysis system. There is also a comparison between white hydrogen and blue hydrogen, there is a initial gap in about 7 years ago that now is filled. The blue hydrogen, for example, is a big project of BP in which blue hydrogen is produced by natural gas, and to reduce the impact of this production, the carbon dioxide is captured and storage permanently in underground. Other technology to transport hydrogen, for example, the pipeline, but with a high and accuracy project to pipeline, because the pressure is around 100 atmosphere to the transportation, and it's also is important to underline that the gas, to make a safety transportation, hydrogen is a highly inflammable gas which must be brought back to a temperature of minus 253 Celsius degree to be liquefied. The Geological Association of America forecasted that the demand of hydrogen would be quintuplied in the next 20 years. Currently, about the 100 megatons of hydrogen are used annually for industrial process. Actually, the cost of white hydrogen is around, for white hydrogen, natural hydrogen, is around $1 for 1 kilo. Instead, grid hydrogen is around $18 by kilogram. So it's very make attention to the challenges, to how try to fit the best way to exploration, and also have a reduce of costing of fracking to white hydrogen that is just a low price, and also we have is the first type of hydrogen with the very lowest footprint. Thanks for attention.